now that you're back from your break, we're going on to example 5, and we're going to determine which rectangle is similar to 4 by 6. So what we're looking for is, can we get them to be the simplified proportion to be the same? So we can see that 4 by 6 is the same thing, since they both have factors of 2, as a 2 by 3. So we should be looking for a simplified proportion between these three of a 2 by 3. If we look at our first one, 3 and 6, the simplified proportion of 3 and 6, we can take out a 3. But this is going to become 1 by 3, and that doesn't match our 2 by 3, so we got to move forward. Our 4 and 1/2, to get to a simplified version that does not have fractions, we're going to actually multiply this by 2. When we do, we see that, so we're going to multiply this one by 2, we divide it by this one by 2. We're going to get 8 by 9. So we went forward. We're going forward in this way because we don't like fractions. We like fractions, but not as much as we like seeing integers to help us determine if we can get to a 2 by 3. Now that we've multiplied this by 2, 8 by 9 can't be simplified anymore. Therefore, cannot be a 2 by 3. We can also see here as a 3 by 4.5. Well, we can, again, multiply by 2, just so you can see a full integer, and maybe then you can see what they have in common. So if you multiply this by 2, we're going to get a 6 by 9. Well, now we're dealing with integers again. And those integers have a factor in common. They have a 3. So we're going to take out a 3 and we're going to get a 2 by 3. So see, there's many ways to get to these proportions, just so you can see which one will go towards being the same scale factor. So this one is the rectangle that is similar to a 4 by 6, a 3 by 4.5. Now that you've kind of seen what we've done here, we are given the lengths and widths of 3 rectangles. 2 of them are similar. For A, so this one and this one, 1 and 2. So 2 of them are similar. But first we've got to manipulate them. Well, we have a 3/4 feet and a 9 by 4 feet. Well, ick. Well, again, we don't like fractions, but they have the same denominator of 4. So I'm going to multiply it by 4, and we're going to get a 3 feet by 9 feet. That's a little easier to deal with. Well, since it's a 3 and a 9, we can take out a 3 to get a 1 foot by 3 foot. So we've got a simplified proportion here. Well, let's see if we can get something else. Well, we have 1 yard by 9 feet. So is it a 1 by 9? No. So we first have to get our units to be the same. So we're going to take 1 yard and know that 1 yard is the same thing as 3 feet by 9 feet. Well, that's starting to look pretty similar. Then, since we've now transferred 1 yard to 3 feet, we can simplify it to be 1 foot by 3 foot. Well, obviously A and B are the same. They have the same proportion. Well, let's check 7 centimeters by 0.13 meters. Well, centimeters is 10 away. So we're going to multiply this one specifically by 10, which allows us to manipulate the decimal. So we're going to get 7 centimeters by 13 centimeters. Does 7 and 13 have any factors in common? No, they don't. So this one does not work. But A and B are proportional to each other. If you feel confident in how 1 went down, attempt number 2 without my help. If not, please follow along. So once again, we have a 4 inch by 5 inch, a 6 inch by 7 inch, and a 1 foot by 1 foot 2 inch. That's a little interesting. Well, 4 and 5 inches. Can that be simplified anymore? They don't have a factor in common, and they're both in inches. Well, B, 6 inch and 7 inches. Both in inches, and 6 and 7 don't have a common factor. Well, that one's done. So these are as simplified as they get. And these obviously don't match. So we need to check C. So we have a foot and 2 inches. Well, 1 foot is the exact same thing as 12 inches. And if 1 foot is 12 inches with another 2, we have a 12 inch by 14 inch. Do these have a factor in common? They do. You can divide each of them by 2 to get a 6 inch by 7 inch, which matches B. So these two are similar to each other, and A is not. So again, we're just looking at the simplified proportions to determine similar polygons. Well, now we're going to get into the fun stuff, because I enjoy solving them rather than just saying, hey, they're similar. So we have example 7 and example 8 to do. Example 7 says we're going to find the value of x and y that makes these two figures similar. What is the scale factor? So first, we are going to make them similar. So we know we're going to have the same scale factor. And we can determine, since this has 2 angles that help us say what sides go with each other, that the 5m and the 8m are similar, the x and the 10m are similar, and the 7m and the y are similar, just based off of where the angles were positioned. So now we're going to set them up like ratios, like what you solved in 7-1. So we can see here that 1 and 1, we have 5/8. So that helps us. Because of this, we can now say it can equal, because it has to have the same proportion as our x and 10. Because they are going to be proportionate to each other. They have to have the same scale factor. This is set up just like solving for proportions in 7-1. So you're going to cross multiply, so we'll get 5 times 10 is 50, which is going to equal 8 times x, which is 8x. We're then going to solve for x. Remember that we need to determine that these 5 and x were on our first triangle. First triangle. 8 and 10 were on our second triangle. But these guys were the same side length. Same side length. That's how I determined how to get to this proportional equation. So now that I've done that, we can divide by 8. And we're going to get x is equivalent to 50/8, which is approximately 6.25. And we're in meters, so we need to give our units. So we found x. That's nice. We got that one. But we also have a y. So I'm still going to use 5 and 8 because it's what's given to us, just in case some mathematical problem goes here wrong and you don't get the right x, and it's easier to deal with than decimals. So I'm still going to use 5/8, and we're going to equal it to, since 5 and 7 are in the same triangle, 7/y. So now I can solve for y. So I'm going to take 8 times 7, which is 56, has to equal 5 times y, which is 5y. Solve for y, divide by 5, we get y is equal to 56/5, which is equivalent to 11.2 meters. So you solved for x and you solved for y. Perfect. What was your scale factor? Well, shoot. I don't want to deal with decimals. But our scale factor was actually our 5/8. Our scale factor was 5/8 because that is what we were setting everything equal to, and 5/8 was as simplified as possible. So our scale factor is 5/8, which helped us solve for x and y. Again, make sure if you have any questions, you come see me on Monday and you email me. If you have determined that number 7, you're like, yep, I got this, move on to 8. Take a moment to pause the video and attempt it yourself. If not, please follow along with me, and we'll finish up this page of notes. So, example 8. The figures are similar, so we know they are similar. And we need to find the value of each variable. Well, we have an x, a p, and a y. And we need to determine the scale factor. Okay. Well, first off, we need to say which sides are equivalent to each other. Well, these angles help us determine that. There is no angle here and no angle here. This says 1 bar and 1 bar. So that means 5 and 9 are similar. And if we continue, we can see that 1, no bar, 1 bar, 3, has to be the same as P because they're in the same spot. It goes all the way around. So that helps us see that all of them are in their respective spots. And we need to find missing variables. Very much like number 7, we just have to find more variables. Well, again, look at our number 1 area. We have a 5 and a 9, so they have to be proportional to each other. So we have 5 over 9. If you remember from what number 7 was, you should know what 5 over 9 actually means. But we're going to start solving for variables. So we have 5 over 9, and I kind of like x to go first. So we're going to say this is equal to x, because it's on the same shape as 5, over the respected 7, where it's on the same side, but same side as 9. It's just a proportion. So you cross multiply, we get 5 times 7, which is 35, equal to 9x. And we're going to divide by 9, so x equals 35 over 9, which is approximately 3.89, and we're still in meters, so we need to make sure we're in meters. So there's x for you. Set up your next one. It should still have 5/9 because it was given to you. So we have 5 over 9 equal, you can either do p or y. I'm going to just start going clockwise. So I'm going to go with 4 and y. 4 is on the same side as 5, so it should be here. And it has to represent with y. We are going to cross multiply. So 9 times 4 is 36, equal to 9y. We divide, which means 36 divided by, why is that 9? It's a 5, that's a 5. Sorry guys, that's a 5. That's a 5. 36 divided by 5. So we have 36 divided by 5, which is equivalent to 7.2 meters. So again, we found y by using that proportion of 5/9. Our last variable we need to solve for is p. So we have 5 over 9 equal to 3 over p. Once again, it's the exact same thing. We cross multiply, we get 9 times 3, which is 27, equal to 5p. We're going to divide by 5, so p is equal to 27 over 5, which is equivalent to 5.4 meters. So we found x, y, and p by setting up the proportions based off of similar sides and their respective spots. What number did we use the whole time? 5 over 9. We used 5 over 9 because it was given to us as the two that represented each other with full numbers, and it is our respected scale factor because it is as simplified as it is, and we knew it has to equal the same proportion. That's how we were able to find x, y, and p. So go ahead and stop for another break. We have one more page of notes that we'll get through rather quickly.